Hello and welcome back to the Reapers. Today I'm glad to have with me my friend Martin. Martin is an aircraft maintenance engineer. Are you with the RAF?
I am, yes.
Roger. And you may know him from, I did a few months ago, I did a video where I visited RAF Bruntingthorpe, or Bruntingthorpe Proving Grounds, where we looked at the Cold War jets which were doing fast taxi runs, and Martin very kindly got me a ride on and a tour of the Nimrod that they've got there, and it was really cool. And yeah, that's that. And because of his job kind of speciality, and just because he's a friend as well, he agreed to come and have a talk. Today we're going to be talking about aircraft, general military aircraft maintenance, fatigue, and maybe a bit of damage as well, if that it comes into it. And I have to say, first of all, precursor to why we're having this chat. So, I'm not a pilot, and I've never really done anything with real planes, and probably never will, but I come from, obviously, a simulation background. Now, in simulators, aircraft are just ones and zeros. You get in your aircraft, you take off in your aircraft, you go and do some dogfights and shoot down some flankers, and then come and land. And that's all you do. When you jump, there's no such thing as fatigue, for example. There's no such thing as maintenance. It's just, you don't think about it. And there are two things that drove me to start thinking about this. The first thing is that in DCS, they've just started putting fatigue in there. So we've got some aircraft now that the wings have started snapping off when you do violent manoeuvres. It's a real pain in the ass, and I hate it, but a lot of the fans seem to like it. The Spitfire, if you pull, it's not actually a G, it's kind of like a jerk movement. If you kind of do enough jerk, more, change of rate of acceleration, something like that, I can't remember. Then the wings will snap off. Harrier, same thing. It's not really G per se, not sustained G. You just put the jerk in and the wings will snap off. Incredibly frustrating when you've just done a 3-hour mission. And even worse now is the Tomcat. The Tomcat, big levers, those wings, and they'll just snap off on you in an instant. And so I did some little bit of research into it, because what I wanted to find out in DCS is why the wings snap off. What is it that causes the wings to snap off? Because you need to know how to avoid it. And it turns out that there is a randomizer in there. Every time you spawn in your new F-14, I can't talk about the makers just refuse to talk to me, but so I've had to do it by trial and error. Every time you spawn in an F-15, you're given a value, an integer or a floating point number, whatever, and that is the fatigue value of your F-14. It could be 1, 10, 100, 1,000, whatever. Okay, I like to think of it as having fatigue points, and you can then fly around and you can do high G maneuvers and jerk maneuvers until that number runs out. At that point, if you do one more jerk, your wings will snap off. Okay, so this means that you could be blessed with a plane with 1 fatigue point, or you could respawn and you could be blessed with 10,000 fatigue points, and therefore your wings could snap off on the first jerk movement or the 20th jerk movement, depended on that value. So what they're starting to do in there is now put fatigue into DCS. So it's something we've actually got to start thinking about and understanding. And the second thing is, even in real life, obviously it's different for you, but for just punters like me that go and watch F-15s flying over and stuff, and F-16s doing cool stunts at air shows, you just don't think about fatigue and damage until I saw my first airshow failure, structural failure, which was RIAT this year, and an F-16C blew out its rear starboard stabilizer, whatever you call them, I never know nowadays. It literally just blew to pieces, and I'd never seen anything like it. I spoke to the particular engineer that went to fix it, and we talked about why it happened, the delamination from this, and it came to, it was just fatigue. It got to the end of it. Again, it's almost given, that stabilizer's given an amount of fatigue points when it's built, and that's, because not every stabilizer is equal. It's a certain amount of points, and after he's done enough 9G moves, enough jerk moves, it just blows to pieces. And that kind of blew my mind, because it's not something you really think about. In your car, which is made of metal, the same as an aircraft, you don't really think about fatigue. Obviously bits wear out, like your alternator wears out and you have to replace it, but you don't, the chassis doesn't fatigue. It's not going to snap in half. It's not going to run out of flight hours. And so that's why I've got you along here. Now, we've got no real format for today. It's just, we're just going to talk through it. So, this is presumably, when we're talking about kind of flight hours on an aircraft. So, is every aircraft that's designed, would you say it's given a certain amount of flight hours that it can do?
Generally, yes. Things have changed over the years, but as a general rule, an aircraft will have a certain amount of life to it. C-17s, for example, from the factory have a fatigue life of about 30,000 hours, I believe. Now, the American Air Force, because they've got 250 of the things, they have a very low usage rate. Because in the Air Force, we use ours ridiculously much faster and put on a lot more hours on them in the meantime. They keep an eye, Boeing keep a close eye on what we're doing and the hours that our aircraft have got and what sort of faults we're having with them, because we are in a much higher usage regime, and so we are seeing faults that they won't, which not necessarily due to fatigue, but as the aircraft ages, certain things will start to fail, which they won't see on any of theirs. And Boeing won't see on any of their light test aircraft because they haven't got anywhere near the hours ours have. Yeah, carry on.
Well, so I was kind of thinking about kind of metal fatigue. What kind of things are you thinking about? Just general engineering failure, mechanical failure?
It can be, yes. I mean, some components will just randomly fail because that's what mechanical components do. Same thing on your car. Aircraft-wise, fatigue is, on large aircraft at least, it's not generally given to be to do with like G-loading and things like that. It's the same on civilian aircraft. It's all done by not so much flight hours, but flight cycles, which is essentially one pressurization, because that's what puts the stress on the airframe. That's where the biggest difference in pressure comes from. They're not out there pulling 9G turns or anything like that. They sit at 30, 40,000 feet for 10 hours at a time, and it's the pressurization where you get that sort of 9 psi differential pressure almost. That's what causes the aircraft stress, and it's the difference going between them from atmospheric pressure up to that differential pressure. And so it will be given a certain number of flight cycles, and it will get, say, NDT inspections, X-ray inspections, or whatever at certain stages of its life, to identify, are there any issues? Is there something like the A380 when it first came into service? They found fairly soon that it was developing cracks in certain parts of the wing, because it's an immense aircraft, and there's only so much that computer design testing can tell you, and the only way to find out what it actually does is to build the thing and fly it. And as they gather the flying hours in the fleet, they'll see trends, they'll see patterns, they'll find a crack in one aircraft, and they'll go and check other aircraft, and they'll find that others have got this as well. And then they may introduce a mod, they'll change the actual design for aircraft that are being built at that time. And it's a continuous program that goes on throughout the aircraft life. As aircraft become older, more flight hours, more cycles, whatever, they will find issues due to that age, due to that fatigue, that will require a change of design. The Vulcan had one, which was never actually added onto any aircraft in service. But because Avro could see that what was going to happen, they knew that after a certain number of flying hours, they would need a certain strengthening repair plate on the leading edge of the wing. They had all the designs for this laid out. None of the Air Force aircraft ever got to that level except 558.
558,
yeah, that one did, and so as they had to do this repair to keep it airworthy while they were flying it. But it's the only Vulcan that's ever had this modification done to it.
Right.
So yeah, it's a constant process as you go through the aircraft life.
Okay, we've got quite a few things to take away from that. So the first question back at you then is, what we're saying is that it tends to be measured, at least in larger planes, which we can work on, cycle size rather than hours. So would you consider a cycle of 1 hour, therefore pretty much the same as a cycle of 20 hours? So, a hop across the channel, that's pretty much the same as a full flight around the world in terms of cycles.
It can be, yes. It's a lot more involved, I feel, with modern aircraft because they've got fatigue sensors on them as well that in the olden days, so Nimrod, right in the middle of the aircraft, as close to the center of gravity as you can get, there is a G counter.
Yeah.
And basically that was the old way of doing it, where you physically monitored what G your aircraft was pulling, and it had little counters in it that would go off at different G settings. So it had 8 different counters in it, just little counters like your electricity counter type thing. And if you pulled, say, 0.2 of a G, it would register one click. 0.4, it would register a different click. And if it was any more than, I think, 2G at the top and sort of minus 0.5 at the bottom, something like that, I think, those would incur maintenance checks.
That's interesting.
Yeah, but it would be monitored what the other ones were reading, and if you were getting an awful lot of say one of the lesser ones, it might incur other maintenance more quickly. So instead of having your pre-planned either calendar or flying hours based maintenance, it might incur some other maintenance earlier on if it's pulling more G than you would necessarily expect. But that was physically monitored with a little counter situated as close to the center of gravity as you could. As you move on, say the TriStar, it was all done with sensors in the aircraft and monitored with a little with a computer on board that would that you'd download at the end of every flight, and that would be your trend analysis, and it would pick up anything that was outside the normal envelope of operation, if you like, anything unusual that you might want to have a look at because it's pulled more G than you would expect it to. And so as time has gone on, the aircraft are monitored more with computers than necessarily a physical counter. So obviously, military aircraft have it sort of different from civvy aircraft because we do different things, essentially.
Well, this is really interesting. It seems what I'm hearing from you is that the fatigue management, recording and management is literally built into the aircraft. As the aircraft is designed, it's going to fly for 30, 40 years, and this whole fatigue in terms of monitoring, recording, is literally just built in from scratch, by the sounds of it.
Essentially, yes. There is also, you have your pre-planned depth maintenance, as it were. So, every, for a 747, every, say, 500 hours, it will go into the hangar. It will have, in the civil world, is what they call an A check. In the military, we call it like a primary, which is a basic, check of the aircraft where you carry out a set number of maintenance tasks, and it's stuff that should be carried out every, say, 500 hours, something like that. It might spend a week in the hangar, and then out it would go and back out for another, say, 500 hours. And it goes through a cycle on the civvy aircraft. It's like A, B, C, and D checks. Where like a D check, it might only come up once every 10 years, and it goes into the hangar for 6 months, that sort of idea. And it gets essentially ripped to shreds, inspected, and then put back together again. And those different checks go to different depths, and a lot of things are programmed to come up. You might say change one of the landing gears at this depth maintenance because it's done a certain number of landings, or that it had to be replaced at some time, and it gets replaced every, say, 2,000 hours, something like that. That's the given life of this component, and so a lot of these component changes are factored into depth maintenance. Helicopters especially, because they are sitting there turning. It's a very vibration heavy airframe, so fatigue in this respect is highly monitored and highly important. And so, lifetimes of components, say the rotor head, that might have, say, 800 hours between bay maintenance, and that all has to be programmed in to your flying program. You're always looking ahead, seeing what's coming up. When's it due? When obviously you can't fly past that, because that's literally the life of the component. So the fleet planning side of things. And I imagine it's the same in Civvy Street as well, because aircraft have only got a certain number of cycles, flight hours, whatever. These things are all taken into account on the maintenance cycle, because you can't just get a brand new aircraft, get to the end of your flight, eject, and go get a new aircraft.
Exactly. Yeah.
So yeah, it's the fleet planning side of things is heavily involved in the maintenance side, because there is so much that goes on to achieve one flight hour. You might have to do constantly, say, 5 hours worth of maintenance.
Yeah, it's amazing how much is going to. I always think nowadays when I go to an air show and see, whatever aeroplane pelting it round at max G and whatnot, just how much maintenance has to be done just for that 5 minute display. Guys ripping
Yeah,
it to pieces and checking it's not done this and it's not done that.
yeah. So I mean, obviously, Chinook-wise, which is obviously what I'm on at the moment, it has a specific display maintenance schedule. It has specific inspections that you do on aircraft that have done displays. And if you compare the current display to one from, I think it was like 2011 was one of the first ones I saw, it's massively toned down because they did some testing and found the stresses it was putting on the aircraft, the life it was taking off the components was a lot more than they thought it was, and so they've had to massively reduce what the aircraft is actually doing during the display. What sort of G it's pulling, what sort of stresses it's putting on all of the transmission components. And so you may have 1 hour's worth of flight time with it, but because it's a display, it incurs, say, a 20% penalty on that. So it's like using 1.2 hours of fatigue time, that sort of idea.
Interesting. Okay. Well, it's interesting seeing that come into our game now, or our simulation. In terms of sensors, I noticed pretty much all of the military aircraft that we've got in our simulator have an accelerometer on there. And just take the Tomcat, for example. It's quite a new plane. And the accelerometer is in such an awkward place, down kind of between your legs, where you could never use it in combat. It's completely superfluous. But what it does have is needles that record the maximum positive and maximum negative. Do you reckon that's more maintenance, or because useless in combat, obviously?
I mean, that is more for the pilots than anything else. That is to give them an indicator of what they've done. So they can immediately say, "Oh God, I've pulled." I'm flying around my C-17, for instance. I've just gone and pulled 5G. I need to get this thing on the ground. It's I don't want to be flying this anymore. I need to get it on the ground because I don't know what damage I've done to it. It's the same on Chinook. We have a CGI indicator, cruise guide indicator, which is basically there are 3 bands on it: green, yellow, and red, and is essentially the amount of stress you are putting through the rotors. And it's in the green, you're fine. Yellow, you're okay, but you want to get it back to the green if possible. Try not to go into the yellow, and if you're into the red, then you need to land because there are we now have to carry out inspections wherever you may be. If you happen to be out in the middle of the country, you put it down in a field somewhere, and you call us, and we have to come and get you out of the shit, essentially, because you cannot fly because you don't know what damage you've done to it.
Wow. Okay.
So those sort of indicators are for the aircrew to give them an immediate idea of what they've done, or what they're doing. You'll find on the Nimrod had one at the front. You could reset it in flight. It's not something they're supposed to do, but they could try and hide something if they messed up. But the G counter down the middle of the aircraft, you can't hide that. That's going to show us what you've actually done. And on more modern aircraft, you can physically sort of take out the data disk, put it into a desktop workstation, and it will reproduce in like a black box style a visual simulation of what's happened based on the data it's recorded. And the more modern aircraft you've got, the more data that they record, and the more you can basically produce a flight simulated version of what the aircraft's done.
Interesting. I mean, it kind of it's almost like kind of breaking your dream a bit, though, because from my layman's point of view, obviously you see it from a different point of view, but from my point of view, when you look at, even in real life, you look at these big things flying about, it's kind of, we come back to the beginning in a way, they look kind of almost invincible. You can see pilots showing off at air shows and stuff like that. But the reality is, these, and whether you're talking big or small planes, these things are all intrinsically weak, aren't they? They're all, if you overstress them ever so slightly, their entropy, it's breaking down, it's breaking apart.
Yeah, it's like your old paperclip thing. You take it, you spread it apart, you bend it back and forth. Eventually, it goes. It's a basic metal fatigue.
Well,
I mean, these things are designed into the aircraft. So it might you might save your wings necessarily could maybe take 12G before they snap off, so you limit it to 9G, and it gives you that sort of that buffer, if you like.
Factor of safety, I guess. Yeah, sure.
Yeah, a safety factor, absolutely. So you've seen probably the testing they do on like new aircraft wings. I think they did it on the 787. They basically take it to like 150 odd percent of its like maximum, if you like, and it should be able to survive that. So it should be able to easily survive nothing it will ever encounter in service. And there's there's a video of I think it was the 787 one where it snapped at like 140 odd percent. And obviously at that point you're like back to the drawing board to figure out why, and how do you change the design to rectify that. So there are so many safety factors built into it. And it allows us a bit more leeway. So you might have your primary maintenance coming up. That's due every 200 hours. We can't necessarily get it into the hangar, or it's needed for something else. And so you can say, right, get someone with engineering authority to sign off to say, right, you can have another 10% on that, another 20 flying hours before it goes into primary. And they'll take into account other things that might be due, what the aircraft's been doing, all that sort of stuff, to decide whether you can have this extension on it. Because all these safety factors are built into it.
So, especially when we're talking about fatigue of an aircraft, if we go back to the kind of root cause, is this because just of the nature of metal? Because it's a plastic, or it acts as a plastic rather than an elastic? Is that what this is all about?
Pretty much, yeah. Because, you see wings on like 747s, how much they, change just going down the runway, how much they flex. Go through a patch of bad weather, bit of turbulence, and they're bouncing all over the place. They have to be flexible to absorb the loads. Otherwise, if they're solid, they just shatter. But when you are flexing things, it has a fatigue life on it. No aircraft should ever get anywhere near the point where something like that will actually happen due to metal fatigue, because what from design what an aircraft is going through.
We've had plenty of lots of planes have failed, even in not too distant years. Well, it has happened though.
Yeah, that is just part of mechanics. Things can randomly fail for things that you just don't know about. Right. It's how deep in the aircraft can you look? There are things even that manufacturers can't envisage. Look at the Valiant, for example. That came into service as a V bomber, and within a few years they found basically the wing spars were cracking. Yeah. And that was the entire aircraft sort of shit out of luck. Essentially, it's just a bad design that had to get taken out of service. But there are issues, and occasionally it will cost people's lives. I suppose. Yeah. I guess it's you cannot predict everything.
Yeah, it's weird. It's weird to think we've got these big things flying around, beautifully engineered and predicted and analysed, and but they're kind of made of this weird material that just dies after a while. It is very. I don't know. It's weird. Coming from automotive background, which is where I come from, you just don't worry about this ever, never. A car will go for infinity, but it's so different to have to worry about this fatigue. Okay. Oh, gosh, so many things jumping into my mind. I don't know where to bloody start. In terms of mods, it's an interesting you picked up earlier. 558, which is Vulcan. It was so. My understanding of the of this 558 is that the Vulcans came into service and then they went out of service. They had a very good service career, very long service career. Relatively trouble free. Good design. And then after they'd gone out of service, civilians decided to bring one of them back into not service, but into a civilian flight kind of display to inspire people like you, I guess, engineers and stuff like that. And it worked really well. It did a really good job. It cost lots of money, millions and millions of pounds and whatnot. But I do remember and the reason they chose this airframe was because it had enough hours left on it. For whatever reason, it had been grounded a lot and hadn't done many missions. It had plenty of cycles, plenty of hours left on it, so they could drive it for so many hours. And I remember reading to get it back into a position where whoever needs to sign it off could sign it off. It had to have what you were talking about earlier, a modification. I can't remember the name of it. That had been that I didn't realise Avro had actually designed. I thought it was them. I thought they had to get engineers to do it, but and they had to. I never really fully understood it. I saw pictures, but get what looked like a great big steel plate, put on one of the wing spars or something. And that comes back to understanding that this problem was going to happen, or this metal fatigue problem was going to happen, I guess, or was happening. I don't know how they found it. And they had to bolt these big plates on, basically. How much do you know about that?
Yes, this is the one I was talking about earlier, when it got to a certain stage of its life, and they knew it would require this design, this modification to it. As I say, the Avro knew about it, they designed it, but then it was never fitted to an aircraft in service. 558, yes, it was when they put it back together again for the displays. Is one of these things they knew about, that when they got to a certain stage of its life, it would require this modification. So they had it planned in well in advance. Mm-hmm. It's one of these things that aircraft designers do. They will have test aircraft. They will have test airframes. So they will build, say, they'll design a new civilian airliner. They will build 5 prototypes to test it all, and one of them will be purely a static airframe that they will go and put practice loads through. They will sit there flexing the wings over and over. They will pressurize it over and over, and they will do vibration testing on it, that sort of thing. They will do all the static testing on it to see what fails, essentially. Where the weak points are. It's what they did with the Comet, to try and figure out why it was crashing so much. And so they took a fuselage, and they've got better ways of doing it now, but they literally stuck it in a water tank and pressurized it just over and over, did all these cycles on it until it failed at one of the corner of the windows. And that was how they did it back then. This was this first idea that aircraft fatigue was a thing. And there were weak points. The windows were square, and it's a fact of engineering that if you have a square corner like that, that's a stress point. That is where your stress is going to go. So all aircraft windows you see are oval, round, that sort of shape. No one uses square windows anymore for that reason.
And now that's really interesting. Now that segues beautifully into my next question, which is, and this is going to be a hard one to answer, and there's not going to be any answer per se, but I'm just wondering, back to the history of aviation, 100 and whatever years now, when did this start? Was it the Comet that kicked this into action? Were there cycle counts and hours in World War II? Do we know roughly when this became a thing, that looking after an aircraft in terms of fatigue and
good question. I off the top of my head, I don't know. I know the Comet was the first, basically was the first one where they really found out how much of a thing that fatigue and stress was, because they were now flying at higher altitudes, faster speed, proper pressurized aircraft, etc. That you just didn't necessarily have before. And so you didn't necessarily have to worry about it. Imagine World War II fighters probably didn't stay in the air long enough to have to worry about it. You're more likely to get shot down than your wings fall off through fatigue.
Yeah, it's really interesting. If you were Mitchell and you were designing a Spitfire, I just think obviously it's designed by engineers, and those engineers would do their calculations to make sure the loads would be satisfactory and within limits. It's just interesting to whether they had the knowledge of metallurgy at the time that could tell them when things are going to fail, how many hours the Spitfire can fly. I don't think we have an answer to that, but it's just an interesting question to ask, I find.
Yeah, and so nowadays what you have when it comes to that sort of idea, you have an aircraft design authority, which is basically an aerospace company who takes on the mantle, if you like, mantle of responsibility for aircraft design. And it's the sort of thing like Boeing or Airbus or British Aerospace. And every aircraft must have this design authority to be in the UK airworthy. So this is one of the reasons Vulcan had to basically stopped its display seasons, was because the companies who were providing that design authority stopped their support. So Rolls-Royce for the engines, I think it was British Aerospace for the airframe. Was it Marshalls? Anyway, one of them, they basically pulled out of it, and so without that you cannot fly. In America, it's slightly different. You can basically slap an experimental registration on any aircraft and do what you want with it. As long as the pilot's happy, you can do what you want with it. In the UK, it's not that simple. So for Vulcan to be able to fly, took an immense amount of work. Getting a company to say, yes, we will sign off this design as airworthy. We will take responsibility for that. We will look at it. We will say, right, you need to do this. You need to bring it up to this airworthiness standard, etc., etc. And so it's incredibly complex in this country to actually get an aircraft airborne.
Yeah, so I hear. This is anecdotal, and I can't remember properly, but I remember when they were trying to get, I think it was the Finnish or Norway, I can't remember, trying to get one of their starfighters going again, which is now going. They could only get it going in America. Couldn't get it going in Europe legally. So they had to go and get it flying. They had to take it to America, get the license there, fly it in America to work out all the bugs and stuff like that, which the cost must have been obscene. Then, finally, once they got it up to a standard, they could send it through and get the European license. But, okay. It's good at the end of the day. It's good to know that a plane's not going to drop on your head on the M1 or whatever. So, but,
yeah, it's from a safety point of view, it's it makes the country that little bit safer, where everything has to some airworthiness authority saying that yes, this aircraft is okay to fly. It's not like South Africa where you go strap a lightning onto yourself and away you go.
Yeah, I mean, it's tough one, that is, because we all want lightning to fly, but we don't want to be hit when the lightning crashes. So
exactly,
bit of a tough one. I don't know what to say about that really, but yeah, interesting. Yeah.
It depends on what side of the field you're on. If you're on the aviation side, you want to see everything flying, without restriction. If you're not into that side of things, then you look at it and say, why are they flying around all these aircraft? They could just literally break and fall out of the sky on top of anyone at any time. Yeah. It depends what side of the fence you sit on, without being sort of blinkered from one side and having tunnel vision, saying, I want this to happen, and I don't care about the consequences. So yeah, it's unfortunate, but it's from a safety aspect, it's one of those things that we have to deal with, I think.
So we've talked a little bit about metallurgy, whatever the word is. Do you ever deal with, because the planes you're dealing with are modern, do you ever deal with kind of new age composites? I know they're not particularly new in aviation, it's quite fairly new in cars, I suppose, but do you have dealings with composites and their maintenance and their kind of fatigue?
We have dealings with them because they're quite common usage on aircraft nowadays. Like you say, I mean, the main structure of something will still be generally metal, but yeah, it's like the rotor blades or non-structural components are generally carbon fiber or fiber reinforced plastic of some sort to try and keep the weight down, because it can still be as strong as aluminium but much lighter. So what? In reference to the F-16, obviously the stabilizers at the back there, the ailerons or whatever their official title is, they were carbon fiber, fiber reinforced plastic, some composite of some kind. And there are lots of issues you can have with that, in that you can have damage to it underneath, impact damage, which doesn't show on the outside. So you can have you can hit it with something. You could drop a tool on it. You bump it into something, and it will have damaged it on the inside, but not necessarily be visible on the outside. You can have moisture ingress into it, water can get into it, and it will over time delaminate it. But again, you may not be able to see it from the outside. And so carbon, this sort of FRP engineering is quite specialised. It's not generally taught to everyone. It's especially repairing it.
It's quite funny because of the similarity there. So I deal with, and I hope to deal with again if I can get my company going again. I used to buy crashed cars, legally written off cars that could go back on the road, and I can repair them. And with the metal ones, it was very easy. With the metal cars, you know what a metal car looks like when it's been crashed. You can see a whopping great dent in it. That's the damage done right there. Good, but. And I never could buy supercars. They're hundreds of thousands of pounds. But when I looked at my auctions, just for fun, I would look at the Ferraris, I would look at the McLarens, the Lamborghinis, and they had been crashed as well. But the interesting thing is, you couldn't see any damage on them. They're written off, and they weren't allowed to go back on the road, or they weren't allowed to go back on the road until a whole section had been taken off and go back on. But you couldn't actually see any damage. They looked perfectly fine. But inside, like you said, something had gone wrong. They had to write it off because there's a big hairline crack in it or something like that. So I see what you mean about a different kind of skill set. But presumably there are specialists, like you said, that deal with these FRP, carbon fibre, composites that have got machines that can detect if there's damage or something like that.
Yes, and again, a lot of these components will be subject to regular testing, and if you suspect anything's wrong, you get the specialists in to have a look at it. There are some things that you just cannot predict with them. So the F-16's tail may have looked absolutely fine, but like I say, there may have been maybe a hairline crack somewhere, something like that, and moisture has gotten in there, delaminated it, and after a certain number of a certain amount of G pulled for a certain number of times, it just gave out. And there is a lot of redundancy built into aircraft. He was able to think, well, hang on a second, there's something wrong here. I've got massive vibration, and it instantly cancels the display, goes and sits at a safe altitude, makes sure he can actually fly the aircraft still, and does a bit of sort of fault diagnosis almost to see what's causing it, and make sure he can still control it before basically attempting to bring it into land. Because if you find it's that bad and that uncontrollable, you don't want to be around the airfield when there's 50,000 spectators there. And so it's not necessarily just in flying controls, but in all your hydraulics, your electrics. There's a massive amount of redundancy for that reason.
It's very interesting how you say that, and it was cool because we, the crowd, became involved. He went through his checks for a quarter of an hour up at altitude. Nothing could go up in that time, obviously. And he came back to the tower, and we were kind of copied into it as the crowd. And he said, look, I can't find out what's wrong with my plane. It's not working, but I can't fly. So the tower said, okay, fly by in a safe manner at 500 feet from the ground, over the runway, fully controlled, and we'll get the crowd, who have got telescopic lenses, to take pictures of it, then show ATC what's wrong with the plane. And they did, and guys, all the nerds with the big lenses took pictures, see that the stabilizer was blown out, and then showed ATC. ATC told the plane what happened, and then they landed it. I just found that was cool, and we all felt really involved in that, which is what sparked this whole conversation off, really, which is interesting.
Yeah, it's a common thing for, obviously not for like the general public, but for air traffic controllers to ask aircraft who have a fault or suspect they have a fault on the outside, which they can't see, they'll do a low flyby and they'll have a look. A lot of the time it can be with undercarriage indication issues, where your undercarriage is down and locked, but you aren't getting an indication. So on the flight deck, does that mean my gear's not down and locked? Is it going to collapse as soon as I land? Is it just an indication issue? Is it mechanically locked down, but the electric, something's gone wrong in the electrics, a microswitch made, and so I'm not getting the indication that it's down. At that point, you're like, well, that's a bit of a risk to take. So you go get someone else to have a look at it, whether you have another aircraft come and look at it, or you do a low fly by the tower, they get the binoculars out and have a look at it, that sort of idea. And so, always err on the side of caution, especially when undercarriage is concerned. There'll be plenty of videos of aircraft with undercarriage that either hasn't come out for whatever reason, or they think it's out, they touch down, and then it collapses on the runway because of the forces going through it, or it can land absolutely fine, and it's literally just an indication issue. It's quite a not necessarily common thing, but it's definitely not the first time it's happened.
Okay, awesome. Okay, I'd say we've pretty much used up our time at the moment. What I would suggest is, that was just really interesting. There's no other way to describe that. And it's kind of, I feel it's going to probably open up a whole can of worms. What we're probably going to find is we put that on the internet and we've got a million questions coming from people. It's up to you, but what would be cool is if we put that out, leave it a few weeks, let some questions mount up, and then we can maybe do a Mark II version where we answer people's questions and stuff. I think that would be quite cool if you're up for that.
Yeah, absolutely, mate. Along with probably coming back to all the things that people say I've gotten wrong at some point.
Oh yeah, but
which is perfectly possible.
Welcome to my life. Everything I do is wrong, but that's how it is. Cool. Really enjoyed that. It's given me it kind of burst my dream a little bit of these invincible things, titans fighting in the sky. In fact, they're really just falling to pieces and waiting to be overstressed. I'm going to go back to my way of thinking about it. Cool. All right, much appreciated, and I'll speak to you in a few weeks, I think.
Yeah, no problem, mate. Cheers.
Right, take care for now. Bye.
Catch you later on. Cheers, mate.